today's topic is counters. What is a counter? As we studied with respect to register, a counter is a cascade of flip-flops which are configured in order to produce a particular output for a particular sequence whenever you apply the application of a clock. Now here, each output of the sequence is dependent on the contents of the flip-flops. That means particular sequence output always depends upon how many flip-flops you have, and it is called as state of the counter. There are two types of counters: binary ripple counters and synchronous. Under binary ripple counters you have again synchronous and asynchronous counters. So ripple counters are also called as asynchronous counters. So in general, binary counters outputs the binary number sequence. Now let us understand from the circuit diagram. Here you can see there are 4 flip-flops synchronized or connected together. Here in asynchronous counters, the clock pulse is applied only to the first clock or the first flip-flop. Here you have 4 flip-flops connected together. The clock is applied to the first flip-flop. The output of each flip-flop is connected together. You can observe here the T output is obtained here. Similarly here, all 4 flip-flops can be obtained together. The outputs Q0, Q1, Q2, Q3 are left out, but the outputs of Q0 bar, Q1 bar, Q2 bar, Q3 bar are connected back to the clock pulse. Now, as we all know that this is a 4-bit because they have taken 4 flip-flops. In 4-bit binary asynchronous up counter, as per the circuit diagram and truth table we can see. Now, see the truth table here. Now these are the clock pulse counts, and you have 4 flip-flop outputs as per the circuit diagram. That is your Q3, Q2, Q1 and Q0 as considered as output. So you can see here Q3, Q2, Q1, Q0. Binary asynchronous up counter, that means the value will be increasing in order because of its a up counter. So you can see the value 00 to 11. So it is in the order of increasing nature. Now exactly the 4-bit asynchronous up counter is working. Let us give clock pulse. As you can see here, synchronous clock pulse is applied. Now when you observe the 4 outputs Q0, Q1, Q2 and Q3, please observe carefully here. At the first clock pulse, you have the Q0 value to be high until the next it is positive edge triggered. You can see here, whenever the positive edge trigger is there is a change from 1 to 0, 1 to 0 with respect to the first output flip-flop, that is Q0. Now you can observe whenever the clock pulses are given, at the first high it is rising and the value remains to be 1 until the next positive clock pulse. So at the point of next clock pulse it is becoming 0. So it is alternating in nature. Now this is Q0. When you observe Q1, what is the output of Q1? You also can see from the truth table here what is the output of Q1. Q1 has alternative 00, 11, 00, 11, 00, 11, 00, 1. Now observe the timing diagram. Here from the first 2 cycles of the clock pulses, whatever you are applying, till that position it will be 00 and 11, 00, 11, 00, 11, 00, 11. When you observe the third output Q2, here you have 4 zeros, 4 ones, 4 zeros, 4 ones. Similarly, the last flip-flop output will be Q3, it will be displaying 8 ones and 8 zeros. So what is happening here? At each pulse the value is increased at doubled here. Now you can observe here, initially it is 10, 10, 10. Next it is becoming 2 zeros, 2 ones, 2 zeros, 2 ones. Next it is becoming 4 zeros, 4 ones, 4 zeros, 4 ones. At the last it is becoming 8 zeros and 8 ones. This is how your 4-bit asynchronous up counter works. Thank you.